Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Newton's laws. Has anyone ever heard of Isaac Newton? You need to know that Isaac Newton developed the three laws of motion. Isaac Newton developed the three laws of motion. Sir Isaac Newton, as he was called, lived from 1642 to 1727. He is known as one of the greatest scientists that ever lived. His laws of motion describe everything from how planets move around the sun to how you can ride a bike, and even why we have to wear seatbelts in moving vehicles. We can all probably agree that motion is something that moves. So what causes motion? We have already learned that motion is caused by forces. Remember, a force is a push or pull exerted on matter. A force is a push or a pull exerted on matter. So Newton's laws really have to do with motion, which is caused by forces. Let me explain. We'll start with Newton's first law. You need to know that Newton's first law is called the law of inertia. The law of inertia. This law states that an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. This law states that an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted on by an unbalanced force. This is called inertia. Write this down. Inertia is the tendency of an object to resist changes in velocity. Inertia is the tendency of an object to resist changes in its motion, whether in motion or motionless. Have you ever stopped on a moving bus and then the bus stops? Well, what happens to you? Yes, you move forwards. You are moving the same direction and speed of the bus when the bus stops. Newton's first law says that you continue to move. Eventually you stop because of another force. So if you throw a ball in the air, Newton's first law says it should continue going up in the air. Well, does it? Well, no. So why does the ball stop and come back down? Well, we call the force that pulls objects towards the earth gravity. That would be an unbalanced force that acts on the object to change its motion. How about another example? Look at this football on the kicking tee. This football would sit here forever. Or how about pushing a shopping cart as hard as you can and then letting it go? The shopping cart eventually slows down and stops. Why then do we observe everyday objects in motion slowing down and becoming motionless, seemingly without an outside force? It's a force that sometimes we can't see. It's the force of friction. You should know that friction is a force that acts in the opposite direction of motion. Friction is a force that acts in the opposite direction of motion. Objects on Earth, unlike the frictionless space, are under the influence of friction. There are four main types of friction. There are four main types of friction. Sliding friction. An example of sliding friction might be ice skating. Rolling friction. An example of rolling friction might be bowling, rolling a bowling ball. Fluid friction would include things like air or maybe even swimming in a pool. Air or water resistance. Static friction is another example. That is the initial friction when moving an object. It's called static friction to get something moving. All right, let's actually take a look at friction. Slide a book across a table and you'll notice that it eventually stops. It eventually stops because of the force of friction. The force of friction brings the book back to a stop. In the absence of the force of friction, the book would continue in motion, the same speed and direction forever, or at least until it fell off the end of the table. Because of inertia, objects, including you, resist changes in motion. So please know that because of inertia, objects resist changes in motion. So when you're going in a car 100 kilometers per hour and you get stopped by a brick wall, your body continues to move at 100 kilometers per hour. You should also know that mass is the measure of inertia. You should know that mass is the measure of inertia. Therefore, an object that has a large mass has a large inertia, and an object that has a small mass has a small inertia. Here's what that means. Let's say a car and a truck both run out of gas. Which would you rather push to the gas station? You'd probably rather push the car, right? The car has less mass, therefore it's easier to overcome the inertia of the car. All right, now how about a truck and a car are slowly rolling down a hill? Which would you rather try to stop? Once again, you'd probably rather try and stop the car. It's got less mass and less inertia to overcome its motion. Let's review. Newton's first law is called the law of inertia. The first law states an object in motion will continue in motion unless acted on by an outside force. So what stops moving objects? We mentioned in this lecture two forces that often stop objects. They are gravity, the force pulling all objects towards Earth, and friction, the force moving in the opposite direction of motion. This ends the lecture on Newton's first law.